Hi dear students, this is Vetri. Today I am going to teach you implementation of list using linked list. In previous class I have explained you we have two different types of implementation. First one is array based implementation and another one is linked list based implementation. See, before going to get into the topic, what is linked list? Linked list is an ordered collection of elements. Each element, each data in the list is referred as a node. In linked list, we used to call the data as a node. Each node contains two different type of fields. Okay, each node contains two different type of fields. So you can look here. See, first field contains data and second field contains address of next node. Address of next node. So the node contains two fields. First field is for data and next one is for address. It will have address of the next node. Okay, and then the basic terminologies. See, what is head field? What is the use of head field? What are the characteristics of head field? Head field, it doesn't have any data. It will not have any data. Okay, it will have address of the first node. Okay, it will have the address of the first node. It doesn't have any data. Now what is this principle on last node? Last node of linked list, it doesn't have address of the next node because it's the last node, and it will have the address field as null. It will be a null node. It doesn't have any link to the next node. Okay, and what are the advantages of linked list? See, insertion and deletion of elements can be done efficiently using linked list when comparing with array based implementation. Okay, and it uses dynamic memory allocation. So we all know that what is dynamic memory allocation? The process of allocating memory to variable during execution of the program, right? During the execution of program, it will allocate the memory to the variables, right? So it will be very effective, and then memory utilization is very efficient. Okay, when comparing with array. And the limitations under linked lists are: linked list does not support a random access. Okay, and memory required to store the next field is slightly complex, and then searching the data from the linked list, it will take much time. It will take more time when compared with array based implementation. Okay, so these are the limitation and disadvantages. Now, type of linked list. See, we have three different types of linked list implementation. First one is singly linked list or one-way linked list, and second one is doubly linked list or two-way linked list, and the third one is circular linked list. Okay, so these are the basic terminologies about linked list. Okay, see, from this diagram you can understand head field, it have the address of the first field. Okay, and then first field, it have the data as 10, it's an integer. It has the address of the next field. Okay, so simultaneously here we have 4 nodes, and last, see, at last, if we don't have any node, see, if we don't have any node, the final one will be null. Okay, the final one will be null. Now let me explain this logic implementation of list using linked list by using the C routines. So okay, by using C program, I'm going to explain how it works. Okay, here we go. First, see here, this is the node which we are going to create now. Okay, So do you think in C language we have any default data type for creating a node? No, right? So we are going to use the structure method for creating a node. Okay, so what is the structure? See, yes, struct see struct node. See, I'm not creating the node, okay, just I'm creating data type for the node, okay, because we don't have the default data type. Now, so after struct node, see, I have two fields, right? First one, I'm going to take my data as integer, so in data, and then so what will be the next node? It's a address of the next node, so I have to keep the pointer struct node next pointer, okay, pointer will have address of the next node, okay. Now I have created the structure now, okay. So the structure will have two fields, first one for data and next one for address of the next node, okay. Now once again for the basic fields, so first one head pointer, and then for new node and for the temporary. So I'll explain you what is the use of temporary pointer, okay, temp pointer. So first create struct node, first pointer name is head, after that new, after that temp, okay. Then I'm going to create one choice option, okay, for continuing the process or not, okay. I'll explain you what is the exact use of that variable, choice variable. Head, initially, look, initially head will not have any address, okay. So head initially head pointer doesn't have any address, okay, it will be 0, head equal to 0. And then now I'm going to make the condition while what will be the choice of the user, okay, choice is equal to 1. If the choice is true, which is 1, then I'm going to create the node, okay. So creating node, which is nothing but I'm going to allocate memory for a new node by using the structure type, okay. Now so new is the next node name, and then equal to, I'm going to typecast the function, okay, which is struct node, typecast is pointer, okay, it will have address of the node. Then malloc is using to allocate memory for the node, and then inside to that size of the node will be, so at initial stage we don't know exactly what will be the size of the node, so I'm going to keep it as struct node, okay. Then after allocating the space for a new data, sorry, new node, I'm going to ask from the user enter the data, then through scanf I'm going to get the variable, my input is going to be integer, so I have to use %d, and now directly I can't use data like this. Okay, so I cannot access the element of structure directly, so I have to use this method. What is the node name? New. Okay, new arrow. So which field? Data or next field? Which is data field. Okay, so that is the format. Now after saving the data, there will be a thing. See, look here. See, I have completed the process of data field, right? Then there is one field which is called address of the next field. Now after inserting the data into the node, that data field, then what will happen? What it will be the address of the next field. Okay, so next field will have new next is equal to 0. So why I am using 0? Because at currently I don't have any next node. Okay, so I don't have any additional nodes. This is the last node. I have entered only one data and I don't have any other nodes to give point to that pointer to that. Okay, now in that case, see, in that case it is enough for entering one data. So these statements are enough. Okay, now if I have more than one data, so what I have to do here? What is the condition? Head is equal to 0. And after inserting this data, okay, after inserting this data, what will be the value of head? Initially head will not have any address. After inserting the first data, head will have address of the first node, right? So I am going to make the condition if, for inserting a new value, okay, if head is equal to 0, then I don't need to disturb the process. Okay, so head will be head and temp is equal to new. Okay, because that's going to be the last node, right, after entering the first data. Else, no, it's not equal to 0. Then, so I forgot to explain what is the use of temp node now. See, look, so temp node is using to swap the pointers, swap the address pointers. Okay, so after inserting the first data, look at the diagram. After inserting the first data, head value become address of this first node. Okay, then when I am trying to insert the next data, see, it will, because the head field will be initially, it will point here, right? It will point here, so it will replace the first node. Okay, then the complex work will be very complex. The process will become complex. So I'm creating temp variable. So temp address field, it's used to swap the address pointers. Okay, now see, temp next is equal to new. Now new node will have, temp next will have address of the new node, and then temp is become the new one. Okay, which was created now. Okay, so now head will point at head position only, temp will have the address of the new node. Okay, so through using this notation I can create multiple nodes without disturbing this process. Okay, so I hope you understood the logic, right? Next. Okay, so that's a process for creating and inserting a data into the linked list. Okay, now after inserting the first data, I have made the conditions through here. Using this condition, I have made the process. Now I'm going to ask the user, after completing this, do you want to insert more data? See, do you want to continue? So yes means 1 or no means 0. Through scanf, I'm going to get the input from the user. It's for choice. Sorry, I forgot the semicolon here. Now, so you can ask why I'm writing this. I can write on top of the function also. See, here I have checked with while. Okay, so just I'm keeping the while condition at top, and then I'm getting the input as last. Okay, now after that, I just want to display all the elements of the linked list. See, temp, initially temp is equal to head, while temp is not equal to 0, while temp is not equal to 0. So what does it mean? Initially temp is not equal to 0, which means, so I already explained the limitation or characteristic of last node of the linked list, right? So last node of the linked list, it will not have any address to the next node, right? It will be 0. So until that I can print the data. Okay, so printf %d, comma, and temp data. Fine. Then after that I have to increment it, right? So first it will print the first data. After that, temp is equal to, it will call the next node, temp next, right? So that's it. So using this notation, we can create the node, we can insert the data, and then we can display it. Okay, so these are the basic method, okay, basic operations available in linked list. Okay, now what are the things we need to keep in our mind when we doing this program? So first we have to create the data type for the node, for node creation, and then we have to declare the pointers head, new, and temp, and then we have to insert the data, and then we have before to that we have to allocate memory for the new node by using malloc function, and then we have to set the condition for head field. Without changing the head field, we have to introduce temporary address pointer, and then after that we are after inserting all the data, we have to display by using the strategies. Okay, so these are the things you have to keep in your mind, and that's it. When the question is for implementation of linked list, implementation of list using linked list or singly linked list, a traversal of singly linked list, so you can write these notations, and then so you can explain with 2 or more examples, right? So I hope you understood the logic and programming structure. Okay, so if you have any doubts, you can comment in comment box, or else you can mail to wingslecture@gmail.com. Thank you. If you have any queries, so don't hesitate to ask. Data structure programs are not easy to understand on a single view. Okay, so you have to keep repeat the things and how the logic works. Okay, so then you will get an idea, then you can start coding by yourself. Okay, so thank you dear students, all the best.